Okay, calculating heats of reaction. Let's look at Hess's law. What it says is if you add up the enthalpy changes for each of a series of chemical reactions, the overall change in enthalpy is the same as if you went straight from the starting point to the finishing point. Okay, what does that even mean? Well, let's say you go from A to B to C to D. Enthalpy for this, we'll just make a easy number. So let's just say that's 1. Delta H for B to C is, we'll just say it's 12. Delta H from C to D, we'll just say is 5. What that's saying is if we go from A to D, it's the sum. We can add up those enthalpy changes and we will get kilojoules per mole. That delta H is going to be the sum. That is Hess's law. But let's look at some rules for Hess's law, for solving a Hess's law problem. So let's look at a problem and then we'll go back to this so we can see what we're talking about. So use Hess's law to find the heat of reaction for the following overall reaction given the step reaction. So N2, now notice this big G, that should be a little g. I was trying to get fancy with this PowerPoint, but they changed all the letters to lowercase, so I apologize. That should all be gas. Let's look back at that. It says label each of the step A, B, etc. if it hasn't been done already. Okay, A, B, they have been done. So, okay, let's go step 2. Look at your overall equation. Look at the first reactant in the overall equation. Find the stepwise equation that has the same reactant in it, the same chemical and same state of matter. Now, it doesn't need to have the same number of moles of that compound, just the same chemical and the state. It doesn't even need to be on the reactant side of the equation. Just find where the same chemical and the same state of matter are. Okay, so the first reactant in this overall reaction is N2. The first, and it also is the first reactant in the stepwise equation. So we're going to write that as given. N2 plus O2 goes to 2NO. Right? That's the first part. We already did this. Determine whether the chemical on the stepwise is on the correct side of the stepwise equation. We did that. Okay, so that was N2. It was on the same side. It was also, so we also wrote it down, N2. Now we could have flipped it, so if it was on the other side, we could have flipped it. If it was on the product side, we could have flipped it, and then we would have labeled it minus A or minus B, etc. So repeat step 2 for each of the reactants in the overall equation. If a reactant appears identically in more than one stepwise equation, skip it for now. The problem will most likely get worked out on its own later. If the reactant appears in a stepwise equation that you've already written down, don't write it down again. So we're only going to write it down once. Okay, so the next reactant here is O2. It's already been written down here, so we do not need to write it down again. Okay, so we can just go on. We'll go on to the next reactants, but there are no other reactants here. So then we go on to the products. All right, now we're going to repeat step 2 for each of the products in the overall reaction. We're going to make sure the product is on the product side of the stepwise equation. If not, we flip the equation, and when we write it down, we use the minus label. So the only product is NO2. NO2, though, is in B, but it's on the reactant side. So what that means is we will have to flip it. So we're going to write minus B, and we'll just flip it, and we'll say 2NO gas plus O2 goes to 2NO2. We have the NO2 on the product side. Okay, now is kind of the fun part. Once all the stepwise equations have been written down, we cancel things out that do not appear in the overall equation. Now, something will cancel out if the chemical formula and state of matter are identical and it appears on a reactant side of one of the stepwise equations and the product side of another. If a chemical appears identically on opposite sides, but the number of compound doesn't match, then you must multiply one of the stepwise equations by a coefficient to get the chemical to cancel out. Now you must multiply everything in the stepwise equation by that coefficient, and also write that coefficient in front of the label off to the side of the stepwise equation. What do we mean by that? Well, let's take a look. Let's start canceling things out. Before that, we have to add it up, though. So we're going to add all these two equations up. What does that mean? We add up the reactants and then the products. So we get N2 plus 2NO plus O2 plus O2 goes to 2NO plus 2NO2. So let's cancel things out now. Notice here the 2NOs are equal, so we can cross those out. And what are we left with? N2. We can combine the two O2s, so that's 2O2, and then we get 2NO2. This matches the overall equation given. All right, so that's exactly what we had. And you might think, well, so what was the point of that? Well, the point is so we can add up those different enthalpies. So now it says once all the chemicals are canceled out that do not appear in the overall equation, we add that up, that's what we have, and we should get an identical copy. And that's what we did of the overall equation. Then, all we need to do is add up the enthalpy to get the enthalpy of reaction for the overall equation. So let's do that. We had A plus negative B equals 180 kilojoules plus negative 112 kilojoules. So that equals 68 kilojoules for the overall reaction. Now this might seem like a lot of steps, but really once you start doing it, it's not really that difficult. You just kind of write it down, you cancel things out, and then you add up the enthalpies. Okay, let's look at another example here. This is from Kendall Hunt Chemistry. Calculate the enthalpy of this reaction, and we're given 3 equations now. So we're going to have to rearrange these to make up the overall equation, this one. So we're going to label each steps A, B, C, not already done. Here we go, A, B, C. Now for the first reactant, the overall equation, we're going to find the stepwise reaction that has the same chemical and the same state of matter. It doesn't have to be on the reactant side of the stepwise equation. So if it is on the correct side, write it as it is, label it AB. If it is on the wrong side, flip the equation, and then if we do flip it, we'll again write minus A or minus B. Our first one is N2. And we see an N2 there. So we're going to write that here. C, N2 plus 3O2, H2 goes to HNO3. And see, we don't have to write it in order as A, B, C. We can write equation C first. Now we'll repeat step 2 for each reactant and product in the overall equation. If a reactant appears in one more or more than one stepwise reaction, skip that reactant or product and move on to the next one. So what's the next one going to be? Oxygen. But we already have oxygen. We see oxygen there, and we see oxygen there. We already have it. So we'll repeat step 2 again for each reactant and product. Here's the product, N2O5. We see N2O5 in B equation, but it's in the reactant. So we're going to have to flip it to make it in the product. That means we put a minus B there as well. So we'll use any unused stepwise equations to get rid of unwanted things. Okay, so we have a lot of unwanted things there, like the water there. We'll put that there, so we have that already. And then the whole equation A is basically unwanted. It doesn't have anything directly to do with the final equation. Cancel things out, fun part. Our goal is to add up all stepwise equations to equal the overall equation. Multiply the equations by a whole number if we need more of something to match the overall equation or to cancel something out. So notice the 2 there. We're going to have to multiply 2C, so we make that a 2N. That's a 6O2, 2H2, and a 4HNO3. And we notice there's a 2N2O5, so we're going to have to multiply that equation B by 2 as well to get 2N2O5 right here. we have what we need up here, 2N2 and 2N2O5. There's 5O2 there, but we see that we will be able to get 5O2 from this equation. So we're good to start the fun part. That fun part is canceling things out. So again, we can get the 5O2 by subtracting, since it's on the opposite side of the equation, we can subtract it. We basically bring that over to the reactant side and we get 5O2. Cancel the H2 since they're on opposite sides of the equation. So we get rid of the H2 and we get rid of the HNO3. We also get rid of the water. Now what do we have left? N2, N2O5, and 5O2. So we have our final equation. We're going to use the stepwise labels as a math expression for solving delta H reaction. So notice, come back here, we had 2C times 2 negative B and negative A. That means we take these values right here, and right here, and multiply by those coefficients to get our final answer. And there we go. That's actually kind of fun, isn't it? I think so. Something you could try at a party. Okay, now let's look at another equation here. We're going to use Hess' law to find this heat of reaction. First, we look to see the stepwise are labeled A and B, so that's good. Now let's start with the first reactant. The first reactant is sulfur, and it's a solid, and that's what we have here. Sulfur, and it's a solid. We don't really care right now about the two. We'll get to that later. So let's write A. We'll just write it down. 2S plus 3O2 goes to SO3. The next reactant is O2. We already have that here, so we don't need to write it again. Those are all of the reactants. Let's look at the products now. The product is SO2. There is no SO2 in the first reaction. There is one in B, but the SO2 product is as a reactant here. So we're going to need to flip that, and we'll call it minus B, and we'll just write it 2SO3 to 2SO2 plus O2. Now we write them all out. 2S plus 3O2 plus SO3 goes to 2SO3 plus 2SO2 plus O2. Now I didn't write the states because I would have run out of room, but we really should write that. Now also we can see that the SO3s will cancel out, and I'm sorry, I should have wrote there. All right, now we can see these will cancel out. If we want, we can also just cancel them out up here. We don't really have to write them out down at the bottom. And what are we left with? We're left with 2S plus 3O2 goes to 2SO2 plus O2. Now we can subtract this O2 and bring it over to the other side. So we have 2S plus 2O2 goes to 2SO2. And this looks an awfully a lot alike the original equation. That's the equation we want. Except there's just a factor of 2 there. So what we can do is divide everything by 2. So divide everything by 2. So we divided everything by 2. That will cancel out, gets rid of these, and we are left with our original equation. But we are not done, because what we did is we have to show that exactly what we did. We divided equation A by 2, and we added it to equation B, which we also divided by 2, and that will give us our answer of what we want. So let's look at this. A is 790, negative 790.4 divided by 2 plus a negative 198. So then we add that up, and then we get a negative 296.1 kilojoules. So we have to show what we did, the fact that we divided both A and B by 2.